Okay, guys, so today we're going to start learning about weight, mass, and gravity. So these are three words that are quite often bandied around by people, and they're often not used in their right context. So we're going to start off with mass. Mass is measured in kilograms. Mass is the amount of, I like to say, the amount of stuff within a thing. So it's the amount of stuff in a thing. So, for example, when we talk about how much what somebody's mass is, what we normally say is what their weight is. So if we say, Mr. Wellard weighs 85 kilograms, that would be a common thing to say. But actually what we're saying is his mass is 85 kilograms. So because we're using me today as the guinea pig, my mass is 85 kilograms. Now, gravity is a force which acts on planetary large enough bodies that things that are big enough to create an amount of force. So on the Earth, it is measured 9.81. And this is measured in newtons per kilogram. So it is a constant on the Earth. Everywhere we go on the Earth, we say the gravity is 9.81 newtons per kilogram. It can be rounded to 10. I tend to use 9.81 because it's more accurate. Now, the weight is the most common one that we actually get wrong. Weight is a force, and it's really important to remember that. The weight is a force. What we also have to remember, so if it's a force, it must be measured in newtons. Now, this weight depends on the mass and the gravity, because weight, as we looked at in a previous video, weight equals mass times gravity. So what we have to do is multiply this number by this thing. So here's a really good example of how mass and weight are quite often go wrong. So you can see I have a little sign on me that says mass of 85 kilograms. Now if I was to hang on my climbing holds, you can see that my mass isn't the thing that actually pulls me downwards. So right now, I've got a mass of 85 kilograms. I don't have a weight on me right now. I've just turned off gravity. So actually, I can do whatever I like. I can swing around all I like really easy. Because there's no gravity, I can do pretty much whatever I like. Simples. Now here's where it changes. Now what about now? Now that I've turned gravity back on in my lab, I now have a weight of 833.85 newtons, which is my mass, 85 kilograms, multiplied by 9.81, gravitational field strength. I now have a weight pulling me downwards because the force of weight acts towards the center of the body that is exerting the gravitational force. Now I hang on this, and it is much harder work. So I can still, the force of gravity is pulling me downwards. You can see that from this arrow. It is pulling me down towards the bottom of the earth. But that's okay, because I can still hold on just. Now what would happen if we put me on Jupiter? Well, what happens is we have a gravitational field strength of about 20.4, I think it is. So our weight would increase to 2,099 newtons. My mass would be about 200 kilograms. Now that's about the same as a sea lion or a giant hog. I'll look that up. So let's see what happens now that we're on Jupiter and I'm trying to hang on. Okay, so at least we know now what would happen if I was on Jupiter in our testing lab. I'd fall pretty quickly. Let's recall. Weight is a force. It's measured in newtons. Mass is the amount of stuff. It's measured in kilograms. Gravity is newtons per kilogram.